Network Security Fundamentals Overview. Network security is the practice of protecting information and systems from unauthorized access, use, disclosure, disruption, modification, or destruction. Modern network security requires a defense-in-depth approach where multiple layers of protection work together. If one layer fails, others still provide protection. This lesson covers the fundamental building blocks of network security, including the CIA triad: access control methods, authentication and authorization, firewalls, encryption, antivirus protection, physical security considerations, wireless security, and virtual private networks. Security objectives. The CIA triad. The CIA triad forms the foundation of all security efforts. Confidentiality ensures that data is accessible only to authorized users through encryption and access controls. Integrity maintains the accuracy and completeness of data using hashing and digital signatures to detect unauthorized modifications. Availability ensures that systems and data are accessible when needed through redundancy, backups, and disaster recovery planning. Real-world example: encryption provides confidentiality, hashing provides integrity, and redundant servers with backups provide availability. All three objectives must be balanced for effective security. Access control fundamentals. Access control determines who can access what resources and under what conditions. The process begins with identification, where users claim an identity such as a username. Authentication then proves that identity through passwords, biometrics, or other factors. Authorization determines what authenticated users can do with resources through permissions and privileges. Accounting tracks user activities for audit and compliance purposes. The principle of least privilege states that users should get the minimum access needed to perform their job functions, reducing the impact of compromised accounts. Authentication and authorization. Authentication relies on three-factor types. Something you know includes passwords, PINs, and security questions. Something you have includes smart cards, hardware tokens, and mobile devices. Something you are includes biometrics like fingerprints, facial recognition, and iris scans. Multi-factor authentication requires two or more different factor types, significantly improving security. Authorization is implemented through access control lists that specify which users can access which resources, and role-based access control where permissions are assigned to roles rather than individual users. Firewalls. Network perimeter defense. Firewalls are network security devices that filter traffic based on security rules. Packet filtering firewalls examine packet headers and allow or block based on IP addresses, ports, and protocols. Stateful inspection firewalls track connection state and context, making more intelligent decisions. Proxy firewalls act as intermediaries between internal and external networks, hiding internal IP addresses. Next-generation firewalls add application awareness and threat intelligence capabilities. The default rule for all firewalls is to block all traffic unless explicitly allowed, following the principle of deny by default. Encryption in network security. Encryption protects data both in transit across networks and at rest on storage devices. Symmetric encryption uses the same key for encryption and decryption, making it fast and ideal for bulk data with algorithms like AES. Asymmetric encryption uses public and private key pairs, enabling secure key exchange and digital signatures with algorithms like RSA and ACC. TLS and SSL secure web traffic and email communications. IPsec secures IP traffic for VPN connections. Encrypting file system protects data stored on disks, ensuring confidentiality even if physical devices are stolen. Antivirus and anti-malware protection. Antivirus software detects and removes malicious software including viruses, worms, trojans, ransomware, and spyware. Signature-based detection compares files to known malware signatures, providing reliable detection of known threats. Heuristic detection identifies suspicious behavior patterns, catching new variants of existing malware. Behavioral detection monitors program actions in real time to identify malicious activity. Regular updates are critical as new threats emerge daily. Antivirus should be combined with email filtering and web filtering for comprehensive protection against malware vectors. Physical security and wireless security. Physical security protects hardware and facilities from unauthorized access and environmental threats. Access controls include locks, keycards, and security guards. Surveillance cameras provide monitoring and evidence collection. Environmental controls include fire suppression systems and climate control to prevent equipment damage. Wireless security protects Wi-Fi networks from unauthorized access. WPA3 is the current security standard providing stronger encryption and protection against password guessing attacks. Disable SSID broadcast to prevent casual discovery and always use strong encryption for wireless networks. VPNs virtual private networks. VPNs create secure encrypted tunnels over public networks like the Internet. Remote access VPNs connect individual users to corporate networks, enabling secure remote work. Site-to-site VPNs connect entire networks between different locations such as headquarters and branch offices. Common VPN protocols include IPsec for strong security, TLS, and SSL for web-based access, WireGuard for modern lightweight connections, and OpenVPN for flexibility. VPNs provide confidentiality through encryption, integrity through hashing, and authentication through certificates or credentials. Key use cases include remote work, branch office connectivity, and secure browsing on untrusted networks.